Arctic summer sea ice has been decreasing rapidly. It had been shrinking at a relatively modest rate of about 3 to 4% per decade. But since 1996, this has sped up to about 10% per decade. From the graph, you can see that the Arctic has had extreme ice loss events in 2007 and in 2012. In 2007, sea ice cover in the summer Arctic was approximately 4.3 million kilometres squared. And in 2012, the ice extent decreased to 3.6 million kilometres squared. If more extreme loss events take place in the next decade, it is not unreasonable to expect that the Arctic could be ice-free by 2025. When talking about Arctic sea ice loss, there are some key definitions to understand. Firstly, that in the literature, an ice-free summer Arctic has generally been defined arbitrarily as having less than 1 million kilometres squared of coverage. This is because some sea ice is expected to remain as a refuge north of the Canadian archipelago and Greenland. Also, Arctic sea ice reaches its minimum in September at the end of the summer ice melt, so a lot of the literature talks about September sea ice extent. And finally, another arbitrary definition in the literature is that a sea ice-free summer Arctic is defined as 5 consecutive years without ice. This is obviously significant, as it would mean that in order to fulfill this requirement, the Arctic would have to be ice-free for every year from 2020 to 2025. Therefore, in this presentation, we only focus on 1 year of a ice-free summer Arctic. Looking back at this graph, we can see that almost all the models show a decrease in summer Arctic sea ice extent in the 21st century, but they vary widely in the year they predict the Arctic summer will become ice-free. The range is somewhere between now and sometime after 2100. The variations between models depends on how the models represent different features, including internal variability, the sensitivity of the system, aerosols, ozone concentration, solar irradiance, and clouds. However, as you can see in the graph, many of these models do not accurately recreate the observations of sea ice extent, which is the black line. In fact, the decreasing trend in observations is 30 years ahead of the models, and this casts doubt on the ability of the models to predict future changes. Although the CMIP5 included more features and more detail than the CMIP3, the multi-model ensemble mean still overestimated the observed sea ice extent, and it did not decrease the uncertainty in predicting the timing of a sea ice-free summer Arctic. Another factor to consider is Arctic sea ice volume. It has been argued that Arctic sea ice volume is a better indicator of sea ice loss, as thinner ice will melt more rapidly, and ice volume has been decreasing more rapidly than sea ice extent. The biomass team found that there has already been a major loss of sea ice volume of about 70 to 80%. While the biomass team does not directly extrapolate sea ice volume loss, Overland and Wang 2013 state that a simple extrapolation into the future shows Arctic summer sea ice is vulnerable within the next decade. Maslowski et al. 2012 argued that the global climate models used in the IPCC did not have high enough resolution and did not include enough small-scale features and feedbacks of the Arctic region to reliably predict sea ice loss. Instead, they used a regional climate model and extrapolated the observations of sea ice volume to predict that the Arctic would be ice-free in summer by about 2016. Although this has since been criticised for not including negative feedbacks, it does demonstrate that a sea ice-free summer Arctic by 2025 is not unrealistic given current understanding. Another method of predicting sea ice loss is through refining the CMIP5 models and giving more weight to the models that more closely match the observations. Snape and Forrester 2014 did this by comparing model outputs to 9 key parameters, including ice area and volume measures and northern hemisphere temperature, and found that when including internal variability in the extreme case scenario, the Arctic could be ice-free in summer as soon as 2021. Finally, Professor Wethams of Cambridge University has been working on Arctic sea ice loss for many years, and he believes that there will be a complete loss of summer sea ice somewhere between next year and 2020.